innovations demonstrated by participants over the past 6 days have truly enriched this academic journey and strengthened the spirit of collaborative learning. Each day of this program has been marked by meaningful discussions, valuable knowledge exchange, and interactive sessions that continue to broaden our perspectives. As we step into today's session, we carry forward the same zeal for learning, collaboration, and academic excellence that has defined this winter school so far. The beginning of a new year offers us an opportunity to reflect, innovate, and embrace fresh idea. May this platform continue to foster innovation thinking, enhance international academic linkages, and contribute significantly to your professional and research development. On behalf of Just Agriculture, ISASTR, and our esteemed collaborating partners, I extend a warm welcome to each one of you to this international training program organized under the theme Revolutionizing Agri System through AI, Digital Tools, and Green Technologies. This winter school serves as a global forum that brings together scientists, academicians, researchers, industry experts, and policymakers. In the present agricultural landscape, AI driven innovations, digital tools, and green technologies are playing an increasingly crucial role in enhancing resilience, improving productivity, and ensure farmer well being. As we commence day 7, we look forward to another insightful and engaging session. Participants will continue to benefit from the expertise of renowned national and international speakers from countries such as USA, Canada, Australia, Egypt, and India, who will share both cutting edge research insights and practical field experiences. The overarching object of this program is to build capacity, promote innovation, lead agriculture, strengthen global academic cooperation, and translate scientific research into impactful real world solutions. We sincerely acknowledge and appreciate the valuable support of our collaborating institutes, VNMKV Parbhani, US Raichur, Laval University Canada, and ICAR NBPGR New Delhi for their continued contribution to the success of this initiative. With these words, let us proceed with day 7, reaffirming our collective commitment towards building a sustainable, inclusive, and future ready agriculture ecosystem. Now, it is a great pleasure for today's session under the AgroVision 2050 theme. We are deeply honored to have with us Dr. Anil Dikshit sir, who is a Joint Director, ICAR, Institute of Biotic Stress Management, Raipur, as our distinguished guest. Dr. Anil Dikshit sir is a renowned expert in the field of plant health management and biotic stress mitigation with extensive experience in research, policy support, and capacity building, and his contributions towards strengthening sustainable agriculture systems and safeguarding crops against emerging biotic challenges have been highly impactful. We are confident that his valuable insights, rich professional experience, and forward looking perspectives will greatly enrich our today's session and inspire meaningful discussions among participants. We welcome you, sir, and the platform is all yours.
Thank you. Good afternoon. And first of all, I would like to give thanks to the organizer, Just Agriculture, that they have invited me for giving lectures on the very valiant topic on the role of artificial intelligence and the digital agriculture in the area of wheat science, because my subject is specialized in wheat science. And I worked there in the Wheat Science Institute for 20 years. Now I'm working as a joint director here in the research managerial position at the National Institute of Biotic Stress Management for the last 5 years. So, dear participants, welcome you all for this International 21 Days Winter School program. And I will be sharing my slides with you. And to it's visible now.
Yes, sir, it is visible.
Okay. So, so my topic would be on the next generation wheat science, speaking about the strategies for the resilient and the climate smart agriculture. So, and here I will briefly discuss about the emerging challenges in the wheat science. Then I will introduce the basic concepts of digital agriculture and the artificial intelligence, and how the specific AI applications in wheat science, and the to discuss about the Indian scenario and the research gaps, which will include the future prospects of the overall my presentation. So, if you know the biotic stress in the institute, we are dealing with the plant protection basically. So, among insect, disease, and the weeds, these three things are there which are coming onto the living organisms, and which is giving the stress to the plants. And several workers, they have uh, uh, find out the different losses uh, of the weeds. So overall, the what the latest figure says that among the 10 major crops in the 18 states, we work it out through All India Coordinated Weed Management Program. So roughly 1 lakh crore is the uh, estimated loss due to presence of weeds. And this is the picture. Here you can say the major loss, 1/3 loss is through the weeds. And if you look at the other insect, 29%, and the diseases, 22%. And the major problem in the weed in Indian agriculture, if we look at, if we talk about the cropland, then Felis manor, which is the major weed for the wheat crop, and Echinoclova colonna is the major weed for the rice crop. And nowadays, the another problem is coming wild rice in the rice field. So that is also some of the very important this thing. Then Ageratum and the cypress, Cynodon, Parthenium. Parthenium is also becoming a very big problem in the crop area also. Otherwise, this is a non-crop weed, but in the cropland situation, this Parthenium has become a very problematic weed. In the non-crop situation, again, the Parthenium, Lantana, Mecania, Mimosa, Ageratum. This Mecania and Mimosa is the problematic in the Assam region. Cromulina is Kerala and the down south region. Then Sacrum and the Paragrass is also very problematic in the non-crop situation. If you come to the water bodies always infected with the water hyacinth, salvinia. These are the some of the weeds which are creating a problem in the water bodies also. And the parasitic weeds, Orobanchi, Striga, and Cuscuta, and Dendrophy, these are the weeds which are creating a problem. Coming to the emerging challenges in the wheat management, the challenges is because of the adoption of dwarf high yielding variety and hybrids, high input agriculture because we have used the increased use of fertilizer and the irrigation, then altered agronomy of the crops, then monocropping and the fixed cropping system. That shift is wheat flora is there. You have a problem example of rice wheat system in the our northern India, how the Felis manner created the havoc in the field condition. Then again, the field, this wheat flora changes is there. If you are using a monoherbicides, then your field crop will be infested with the dicots crop. So likewise, wheat flora shift is there whenever you are using a different kind of herbicides. Then development of herbicide resistance is also there. This is also another issue. Then herbicide residue hazards is there because many times the phytotoxicity also plays a very important role. Here in the Hoshangabad region recently, there was a one case of high dose of on ethyl used in the soybean crop, and the whole soybean crop was damaged. And our honorable minister was very much concerned about that incident. So likewise, many times we come across such kind of accidents. Then growing infestation of weedy rice, which I told you, then invasion of alien weeds and the implication of climate change, how the C3, C4, C4 weeds will have impact on the changing climate scenario. And if you talk about the stakeholder concern, then invasion of a new weed species, rising cost of manual weeding, because the manual weeding nowadays is impractical. No one can afford to have a manual weeding. So ultimately, we have to have other challenges and the demand innovative and the precise solutions. And here the role of artificial intelligence and the use of robotics and the drone application plays a very important role. Then the application technique of herbicides this is again a very important topic. Whenever I used to go to the farmers field, I used to tell to the farmers that how you can use the herbicide in a precise way, because the pesticide application is if you talk about the insecticide and other pesticide, then it is different case. But here in the case of herbicide, you have to have a certain knowledge nozzle, and yeah, your dose should be very precise, and the herbicide calibration, that is very important. Then only you can get the 100% result whenever the weed control is the concern. Then spurious chemical is always very much concerned for the stakeholders. Then costly herbicides, the large packing of the herbicides, that is also sometimes handling is difficult. That's why the company people, they are making a packing of the herbicides in a such a way that becomes a handy. Then registration of new molecules, that also takes a lot of time and lot of money is involved. Means at least 8 to 10 crores of rupees for developing any new molecules is required. You have to have a different location specific data, biophysical data, then toxicological data. So likewise, you have to have a set of data application, then only you can have it. Then lack of awareness, then extension efforts, then weed is basically no man's land. So in that area, nobody gives the concern how about the control of weeds. The future technology innovations, I have pinpointed some of the things which are taking place in the area of new next generation wheat science. That one is the biotechnology. We are talking about the stack genes. In fact, I also had a opportunity to develop, means work together with the multinational companies with the developing the two stack gene. One was for the transgenic corn, which was having a resistant for the herbicide tolerant crop. Then another was the for the stem borer. So likewise, the stack genes business is there in the area of biotechnology. The nanotechnology, nanoformulations are coming up, and how the minute doses can play a wonder role. Already the nanotechnology approach is there in the area of nano urea and nano DAP. Likewise, the another some the chemical ecology and the chemical engineering concern, they are developing those kind of molecules. And novel chemistry, we talk about the novel chemistry, then we talk about the green chemistry molecule, that which is of low doses and giving the lowest impact on the environment. So that is the very important. Then CRISPR-Cas9, RNAi, omics technology, then development of micro and bioherbicides. Many this microbes, they have found to be a very effective in terms of concern. So definitely those can be very well this thing. Then microwave and the laser, then robotics and drone, I already told you. then the intelligent agronomic practices where we can have some manipulation of the your plant population and the seed rate, then how best we can have a good agricultural practices that can play a very important role. Then allelopathy also is the area where we can have develop some of the good formulation. But so far, many people have worked on the allelopathy aspect here and the abroad also. But in the India, we have not come across to develop a commercial formulation of any allulochemicals. So this is again an area which we can have it something. Now the coming to the conventional herbicides which are having a weed control, right? The butachlor, petlachlor, pendimethalin, enilofas 240. These are the age-old molecules which were giving the control for the weeds in the rice crop. And now the new low-dose high-potency molecules are there in the market: bisbyribec, sodium, phenoxaprop, cyhalophos-butyl, azimsulfron, pyrazosulfron, ethoxysulfron. Then the combination products are there. So likewise, these are the different list which is there. Now coming to the key elements for the transformation, how the conventional agriculture coming to transform to the conservation agriculture. Here in the conventional agriculture, we were using the excessive tillage operation, then residue burning and incorporation, then XC2, FIM compost, and the green manuring incorporation. But again, in the conservation agriculture, we are dependent on the three basic principles, which is the minimum tillage and the high residual moisture, which is being used for the covering the soil with the your mulching, and no tillage is the basic concept of the conservation agriculture. Then ultimately this we have to have a brown manuring, or either we can use the 2,4-D or the other chemical which kills the dhencha or the any green manure, and which will be later into the already surface drying will be there. So automatically that will be adding to the composting kind of material to the crop. So ultimately, when we talk about the climate change and this thing, so there are different responses of weeds to the increase of temperature is there. And here the in general, the increased temperature favors the C4 weeds, because the C4 weeds we have already seen in the many area that how these are giving a good growth whenever the temperature elevation and the carbon dioxide concentration elevations are there. And again, the infestation of C4 weeds such as the panicum and the Gigeria, Amaranthus, Ceteria, and the Sorghum helipens are likely to increase further. And Datura stramonium, a weed that exhibits the high growth under the high temperature. This is again the observations by the one of the worker. And then emergence and the flowering of Chenopodium, which is a broadleaf weeds, it's advanced to 26 to 50 days, so respectively by increase of the temperature. So these are the some of the findings, and how the herbicide efficacies are affected with the high elevated CO2 and the temperature. Here the bisbyribec sodium for the Dynebra is no effect there, but delayed response is there in terms of Echinoclova colonna and the Alternanthera sessilis. Likewise, for the Tembuteron and the isoprotron, the delayed response has been noticed by the increased temperature and the increased carbon dioxide for the Dynebra and the Phallus minor. Then response to weeds for rainfall pattern and the drought is also there, that high water use efficiency for C4 weed and the drought-like situation will favor the C4 and the parasitic such as the striga. And the rice plants were unable to survive under the low moisture conditions, that is 25 to 12.5% of the field capacity. And whereas the Amaranthus spinosus and the Leptocola chinesis were not only able to survive, but also produced a sizable number of branches, tillers at the same level of the moisture. Then the modern approaches used for the host plant resistance. These are the already I told you these are the techniques in terms of the genomics and the omics and the CRISPR-Cas9 techniques can be used for the molecular level. Then again, the major herbicide tolerant crop, these are the some of the crop which are tolerant to glyphosate and the dicamba 2,4-D. And mostly the glyphosate and the glufosinate. These are the two molecules which are being used for developing the herbicide tolerant crop, whether it is a soybean, it's a mustard, or the other crop, cotton. This is the current status of the herbicide tolerant crop in India. So basically, officially released the ST crop. Basically, this is the non-GM herbicide tolerant rice. Is the only approved herbicide tolerant crop, like Pusa Basmati 1979 and Pusa Basmati 1985 and CR Khan 807. This is tolerant to basically imazethapyr. So it is a basically non-GM crop. It's not a 100% GM tolerant crop. Then ST mustard is there, ST cotton is there. So these are the some of the development in terms of the herbicide tolerant crop in India. And because of the policy and the regulatory framework here, we have a certain restriction, and the glyphosate restriction was also imposed in 2022. License to pest control operators, limiting farmers' access. Then role of research institutions, where we are having ICR, then the state agriculture universities and the seed industry that are progressing with the ST crop research. And the varieties which I told you earlier, these were the released with the help of CRRI Cuttack and the IRI Delhi. So these non-GM rice GM options are there. Basically, that is tolerant to imazethapyr. And farmers' opinion, many organizations and the many studies have carried out. So basically, farmers are worried about the labor problem. And if we will say to him that you go for the hand bidding and all, he's not going to convince that one, because he cannot afford it. Labor scarcity is the biggest problem here in the country and the abroad also. And abroad, the ST area and the other area is too much. So there is no this thing. But in our country, we have limitations to use the ST crops. But the farmers are in favor of this kind of technology. Farmers wants that the whatever the technologies are there, at least he should be given the chance. Means if you go to the mobile shop, if you are being asked to have a Nokia, Motorola, Apple, and whatever it is, and if your pocket allows, so you can buy the n number of mobile, and the you can have access to any company. So that kind of option should be there to the farmers, that yeah, if he want to, if he can afford to have a GM seeds, then definitely he should be given the chance. So, but again, the different opportunities, different risk, it is there. But those risks, and it is there for the every technology. There are pros and the cons, but we have to see if you can make a your charter sheet, that what are the plus points, so what are the minus points. So plus points are more. So likewise, you can have it such technology for your this Indian agriculture in a faster way. These are the benefits. Already I told you in my speech that how this labor savings are there, then it can reduce the crop injury, and you cannot dependent on the n number of herbicides, which I showed you in the previous slide, that you are having a different kind of your n number of molecules. You have to remember that whether it is a pre-emergence, post-emergence, and some molecules are not effective against the different crops and this thing. So likewise, you cannot you not to dependent on that one. It's simply you have a glyphosate or the glufosinate tolerant this herbicide crop, then and you can use it very well. So this is the future prospect that we can have a develop region-specific basmati line, then strengthen the mustard research, because the mustard these are the area where we had a lead on this aspect, and definitely the training part is very important to use this KVK and the FPOs and the digital platform to abort such technology. And these are the some of the pictures how the happy seeder and zero tillage technology is used in the farmers field, that how the zero tillage also plays a very important role. This I'm giving you the overall scenario of the weed management program first, then I'll switch over to the my this another topic on the artificial intelligence and this thing. So likewise, these are the this thing there. And here the basically the overall the knowledge of weed science depends on the basically integrated weed management. So we give the focus on the integrated weed management, whether it's starting from the prevention is better than cure. Then we have a mechanical and the manual option, where there is a summer plowing and the other aspects of the tillage, mulching, and the solarization. Then the cultural options for the good agricultural practices for the stale seedbed and the competitive cultivars, and the use of different crop and cultivars which are faster in growth and which can suppress the weeds in at the initial stage, because the first 40 days is most critical. That is very important. Then only you can have a better weed management program. And the herbicide business I already briefed you. Then biological is also one of the means where we can have a good way to control the weeds. The Zygogramma bicolata, one of the beetle, was the successfully demonstrated at the farmers field and the different locations, that how beautifully it was feeding on the Parthenium. Initially, there was a controversy that this beetle feeds on the sunflower, but later on it was ruled out that no, it has only host-specific this thing, and it feeds on the Parthenium only. Because the successful weed biological weed management, or any biological pest management program, you should have a host specific agent, then only it will give the 100% result. So this is the tools of overall biotic stress management. We've talked about the first slide. The previous slide was the on the weeds, and this is the because I'm dealing with the institution where we used to deal with the other area of the biotic stresses also, whether it's insect and disease. So basically, the if you talk about the smart and the advanced tools, so IPM-based decision support, drones and remote sensing, and ICT-based pest forecasting and advisory, and RNAi CRISPR approach for the nano formulation. These are the some techniques which are being used for the upcoming program for the biotic stress management. And then there are some technological advances which allow the integration of the ecological approach for the weed control technologies, such as the spot and spray and see and spray technology, and the variable rate applications. That's come the, when we talk about the site-specific weed management and this thing. So these are the some of the. Now that I'm talking about the digital technology for weed management, which is important aspects that how the artificial intelligence is one of the key area of research in computer science, because of its rapid technological advancement. And artificial intelligence basically refers to the ability of the machines to perform the task that would normally require the human intelligence to accomplish. So basically, this include a range of activities such as visual perception, speech recognition, and the decision making. So and many more. So based on these interventions, we can have a achievement on the soil management, weed management, and the use of Internet of Things. So these techniques can be used for the weed control cultivation and the climate and the other business. So it has a lot of potential in agriculture and is already being used in various ways to increase the efficiency and the productivity. So, so coming to the digital technologies, so here the digital technologies has been shown in the advancement of the use of drones, then sensor, then image analysis software, uh, artificial intelligence, and the machine learning, data handling frameworks, and the cloud computing. So these are the basically interventions in the digital technology is there. Then digital agriculture basically allows to capture this variability and they respond in a various way. So basically, precision is no longer option. So it is essential for economic variability and the environmental sustainability. And ultimately, the digital agriculture refers to the integration of the information technology and the agriculture practices, which includes the tools such as the GPS is there, GIS, their remote sensing, then field sensor. So these technologies generates the large volume data. So ultimately, the real value lies on the converting this data into actionable decision at the field level. Then only the success of this kind of technologies is there. Otherwise, it has no meaning. And artificial intelligence, when we talk about the artificial intelligence, so basically it consists of the machine learning, deep learning, computer vision, and the predictive analytics. So in simple term, basically the AI enables the machine to learn the pattern from the data and make decisions. So this is the idea behind that. And in wheat science, this capability is highly valuable. Why? Because weed identification is important, then emergence prediction is important, and then resistant detections are essential. So then only you can have a pattern recognition problem. So this kind of recognition is very important. And in weed management, it requires the species level precision. Then only the artificial intelligence can give you the better result, because it has to be identify at early growth stages, then differentiate from the crop. That is very important. Then recommend the targeted intervention. So ultimately, AI enables the site-specific herbicide application. That I'll tell you the how the this broadcast the herbicide application, this pre-emergence herbicide application, then the post-emergence herbicide application. So ultimately, the different work is there, because here a very less work has been carried out by the different workers in our country, but abroad they already they are using it the larger scale, and they are using it in a very precise way, and they are getting a very good result also, because the success for this AI or the digital agriculture is depends on the large volume data and the how data has been generated. That is only important. With the less data, you cannot have a precise technique for the any kind of this thing. Then weed recognition and the mapping. So important for the site-specific management and basically mid to late season weeds that are sparse. So blanket applications are not economical and environmentally less benign also. So here you can have it with the precise application of the artificial intelligence, and this is basically one of the most promising application of the AI in the weed science for the image-based weed identification. Then AI model can classify weed species from the images captured by the smartphones or field cameras. So this field level variability remains unchallenged. This is the workflow, how the images can detect the model, and then geo coordinate extraction there, then the SHI file overlaid over the orthomosteric image. So this is uh, precise application. Then real-time detection and the spraying. This is the conceptualized model, how the onboard processing is there with the real-time weed detection. Then remote sensing team will have a planning and the flight, then onboard processing data transfer to the cloud, then data retrieval using the web app and the data loading on the RPass. That is a programming. So in this way, the whole things can be basically the computer vision process begins with the image acquisition. So relevant features are extracted and the model is trained and validated. And weed detection approach here, you can canopy and the reflection characteristics there, and vegetation indices there, RGB and the multispectral. So here different uh, unmanned aerial vehicles and the drones provide a powerful platform for weed mapping at the field level and the landscape level. And multispectral and the hyperspectral sensors helps the distinguish the weed from crop based on reflectance pattern. So ultimately, this particularly useful in the large farm or the conservation agriculture system, and where the scouting is difficult. There we can have it in a very precise way. Then weed detection based on the machine learning. So artificial neural network and the means ANN and CNN. These are the two platforms where we can have it, the weed detection technique. And several parameters are used for the machine learning model. So ultimately, it needs a large volume images for the model training. Without that, it is very difficult. So this is one of the machine, the AGIR, a National Weed and Crop Image Repository, and the field image collections are there likewise. This is all abroad work. This processing, how the incoming images are there, then image processing is there with the label assistant and this label synthetic. And you have a library, then data, and then you have to repeat the whole things. This is the National Weed and Crop Image Repository, and the many organizations are working. The Precision Sustainable Agriculture, Grow, Agriculture Research Services, Auras University, Texas. Then International Weed Recognition Consortium is there. Their vision is to basically promote the development and use of digital imagery for advancing weed research and the precision weed control applications. And here in the International Weed Recognition Consortium, the Canada and Brazil, uh, Denmark, China, India, the Weed Science Institute is there, South Korea, CGIR, the Erie Center is there, Philippines, then Australia, from the Western Australia. And this is the synthetic image generation. Then this is the data from the CNN and the NN based model, that how the morning glories and the grass weeds in cotton. It's differentiate in different colors through the machine learning technique. This is the 3D images of the virtual field. You can look at the different colors, how it looks like. Then biomass of the 3D method comparison, that how you can make it differentiation. This is 3D field mapping and the 3D plant mapping. Then estimation of wheat seed production. Then how this basically the estimation of wheat seed production is again you have to have a basically different set of data. Then ultimately the two fields may look similar. So basically idea is that to have a future infestation can differ drastically depending on the weed fecundity and the seed rain. And there we must quantify the weeds from the intelligently. And this is where the machine learning and imaging come into the play. So, this is important. And the herbicide injury evaluation is also can be done. The how the 2,4-D and the isoxolate and the dicamba. So that has given this thing, and injury is, you can look at the different color from low to high. So based on the different color, you can judge that how much damage or phytotoxicity is there with the use of different then management aspect, drone and the ground platforms, and here the as per the DGSSC CA requirement, the different requirement is there, and ultimately the operating instructions are there, that 5 kilometer from the airport and the 25 kilometer international border, and 3 kilometer military establishment, 3 kilometer state secretary. So this much you have to follow the distance, then only you can use the drone in different places. And their breach of compliance have a different IPC role, and now the IPC has been changed to BNS. So likewise, you can be taken into the task, and pilot should be of 18 years age, and at least you should have passed the 10th exam. Like that, different requirements are there. And if you talk about the drones and robotics, so ultimately AI is basically not only automatic, but it's more than like a human. And ultimately the AI is the decision making like human only, and intelligent program follow the algorithm based and the human approach of the problem solving. And robots are used for computing the hardware and sensor, and the ultimately the limitation is there ki, this AI cannot be a versatile like a human. So ultimately human brain is very important, then only you can have it. One can ask that can AI replace the wheat scientist in the future? So it is not like that. No, AI cannot replace the wheat scientist. AI basically identifies the pattern, and but it cannot understand the weed ecology, crop weed competition, or the long-term sustainability. So without wheat science expertise, AI model can give misleading recommendations. So ultimately, wheat scientist or the scientist has to must lead AI into integration only. Then only we can have a real picture and we can get the good results on the field. Then we talk about the site-specific treatment of the weed. So ultimately, the site-specific herbicide application is the um, main aim, fundamental principle basically is the right herbicide, right dose, right place, and right time. Means 4R. We used to tell the 4R. What is the 4R? Right herbicide, right dose, right place, and the right time. So this approach relies on the three core steps: detection of the weeds and the decision making based, and ultimately to target the application using the variable rate application, which I told you earlier. So ultimately this has to integrate with the geospatial technology, sensor, and the machine learning. And ultimately the for site specific herbicide applications, weed maps are generated for prior spraying, and ultimately the weed distribution is addressing using the UAV and the satellite images. And these weed maps classify three categories are there: weed free, low infestation, and the high infestation. So based on these three category, weed maps are prepared, then only it can be used. This is the robotic system for the site-specific herbicide application. So robots also be used in a the same way of the principle. So this is the conclusion that the integrated weed management involving the chemical and the non-chemical method. So ultimately the CA-based application is important, that how the machine herbicides and the management driven agriculture is important. Then if you talk about the global trends in the weed issues, which requires the advanced technology, then again, we have to have a GPS-enabled sprayers and the um, skill data processing. That is very important. Then only you will get the good result. Because here in the AI application and the other things, the you have to have a ecology and the digital tool and the precision agronomy. These three things are very much important to get the best result with the site-specific weed management or the whatever the AI and the machine learning is there. And ultimately, challenges are there, and more R&D work is required. It's not a uh, one-day job or the job which can be you may have it in this thing. So ultimately, the success lies on the uh, real data analysis. Real data analysis, that is very important. You should have developing the national data weed database and the funding interdisciplinary projects, then the incorporating the AI modules into the training program like winter school, which you are attending today. And really, I'm complimenting the Just Agriculture that they have chosen a very right kind of topic, which is of the today's demand, that how best we may use the AI-based science in the agriculture field. So this is the last line of the Albert Einstein, that we cannot solve our problems with the same thinking we used when we created them. Thank you very much.
Thank you so much, sir, for this wonderful lecture on next generation wheat science, strategic for resilient and climate smart agriculture. And I would like to say to the audience that if anyone have any questions, then they can drop in the chat box. Anyone have any questions? Sir, there is a question from unknown user that how marginal and small use drone.
Yeah, this marginal and the small farmers, they have limitations to use the drone technology and what we were talking about. But certain in the larger field, we use it. But for the small holding farmers, they have a limitation to use the drone technology.
And sir, there is also one more question from Dr. Ankit Kumar that if anyone applied herbicide in wheat crop for controlling of wheat at 30 to 35 days old crop, by mistakenly they applied more dose after days. Crop is showing burned and mortality condition. What is solution to maintain the crop loss?
Yeah, we have a limitation in using the antidotes whenever we come across for such kind of phytotoxicity effect in the field crop. But certainly there are some glucose solution which can be used, 20% glucose solution in the field, that reduce the losses, phytotoxicity effect in the main field crop. But again, I told you that herbicide application technique is very important. So there you have to play a very important role. Means the you should avoid the application part in a very casual manner. You should have a flat fan nozzle. Then your dosage should be very well scientifically this thing. Then you will get the desirable result in the field condition.
और सर एक और क्वेश्चन था कि फॉर वीड क्रॉप व्हिच वन इज बेस्ट पोस्ट emergence broad spectrum herbicide?
Wheat crop.
Yes, sir.
Wheat crop, we have a some carfentrazone is there. Then we use chlorinoform. Then one chemical herbicide is there, Atlantis. So these kind of herbicides can be used in wheat crop for controlling grassy and broadleaf weeds.
Okay, sir. And sir, there is one more from Vikas Kharb that we talked about AI system being efficient, but isn't the cost of the technology and the software so high that it actually more expensive, especially for Indian farmers?
Yeah, basically the AI application in the wheat science, it gives the good result. But the considering the cost and this thing, that's why this technology is meant for the large farms and the big farmers. They can afford it, and they may get the good results.
Okay, sir. And sir, what is the effect of pesticide and herbicide on the consumers?
You see that as per the CIB, Central Insecticide Board guideline, the any molecules which comes into the market, it has to go with all sort of bioefficacy data, field validation at the different location, then toxicological data, and study on the effect of soil microflora also. Then only those molecules are registered. So the chances of getting any kind of contamination in the food chain or the human this thing, it's very minimal. But again, sometimes we come across such kind of incidences. But again, I tell you, the herbicides are the most safest chemical if you look at the different kind of pesticide group.
Okay, sir. And also, sir, what type of formulation is most suitable for drone spraying and why?
The formulation generally we use for the drone application is the liquid formulation only, because the spraying is very easy with the help of this thing. But in drone application, the initial drone launched in the India for the nutrient application. Later on, we introduced for certain pesticide, and for the herbicide only we have introduced for two herbicides only. One is the bisbaribak sodium and another one is the pyrazosulfuron. So these two herbicides are being used for the drone applications, not all.
And also, sir, could you please suggest any platform to learn more about next generation weed science?
Yeah, Wheat Science Institute is there at Jabalpur. They also organize some of the training. Just recently, today only, I got the from NIPHM is the platform. They are also offering the advances in the wheat science 3 days training program. You just Google it, NIPHM Hyderabad. So they have notified that how best you can have advances in the wheat science, and they are going to have it, I think, from 17th January. Just today only I got their invitation.
Okay. And also, sir, like you said, that herbicides are the safest one. So someone is asking that, how, like you can, like how you are saying that the herbicide is safe for
No, no,
soil and
I'm
flora
not
diversity.
saying, I'm not saying, you see, the Central Insecticide Board is the only statutory body in the country. they used to give the color to the different pesticides. If you look at the pesticide boxes, the boxes have a color toxicity, that most of the insecticides grouped under the red and yellow, whereas the herbicides are grouped in the blue and green. So red one is the highly toxic, then yellow is the less, then blue third one, and the safest is the green one. So based on the color coding only, I'm telling you, and I know that how the herbicides, because the herbicides are being used as a pre-emergence and the post-emergence, and the maximum timing which we are applying herbicides is the 30 to 40 days. So here insecticide are being used directly on the final product, whether it's suppose bhindi crop is there and bhindi is infected with the insects. So ultimately the farmers, they are putting chlorpyrifos or the other imidacloprid directly on the bhindi or the tomato or the whatever their final products are there. So those chemicals are more dangerous as compared to the herbicides.
Okay, sir. And sir, there is one more question from Vikas Kharb that India uses much less herbicide per hectare than countries like Japan. Yet
Yes.
our exports often fail quality test due to high chemical residues. So is the problem the type of chemical we use, or is it lack of training for farmers on when to stop spraying before harvest?
Well, definitely, both the things are there. It's again depends on the quality of the chemical, because in the our country we are getting a lot of spurious chemical. You might be heard that long back we heard about in Punjab about the spurious chemical, and the one of the topmost agriculture officer was involved such kind of this thing. So my point is that you have to have a best chemical whenever you are using it in the field crops, whether for the insecticide or the herbicides. And again, your kind of technique, which is also very important.
Okay, sir. And sir, Dr. Yogesh is asking, does crop height influence drone flying height?
Does crop?
Does crop height influence drone flying
No,
height?
no, no. Crop height is not more than 1 meter, so it is not going to affect the
And
much.
sir, yes, sir. And sir, Rajeshwar sir is asking that can we use herbicide in natural
No,
farming?
no. You see, the basic difference in the natural farming and the organic farming is that organic farming, you can use it the any organic product from the outside. But in the natural farming, the basic principle is that you have to have all your resources from the same field only. You cannot use any input from the outsource. And chemical sources is not at all permissible in the natural farming.
And sir, also is the drone accessible to low income farmers, which is the highest in India? What is government doing in their field?
Drone for the which farmer?
Yes, sir, drone accessible to low income farmers.
Yeah, government of India is granting the I think subsidy over it, and they have some custom hiring group also for using a drone application for the small holding farmers.
Okay, sir. And sir, also sir, is any biological herbicide molecules available
The biological
commercial?
herbicide molecules commercially available, but those are not effective. So we again don't use such this thing. Those are this trichoderma based some formulations. They have, company they have made it. But as far as for the wheat control aspect is there, but those are not effective. But as a biostimulant, as a growth hormones, those products are very much available. But again, the government has put the restriction on the use of bioformulation and biosurfactant. So again, they have made a committee, and again, the government of India is again reviewing all those material because many formulations are there in the market, and they are making a farmers to buy those bio formulation and the bio product in the name of that giving a better growth or the high growth like that. So government don't want that one the manufacturer befool the farmers, because the farmers is very innocent and they easily believe on the whatever the company this traders they are used to give the points.
Sir, I guess there will be more queries. So, is there any platform where people can connect with you? So, like,
Yeah,
if
you
there,
can you can have another session for me, no issue. But you have my number. They can easily on call me, and I'm easily available because I used to get a lot of phone calls from the farmers also. So I don't have any reservation on it. You can
and
share.
sir, I guess there is a last question that is there
Yeah,
a
I have a one meeting also. Huh?
okay. Sorry, sir. So, as sir said that you can contact them
Yeah, yeah.
and yeah, yes, sir. And sir, with this, I really thank you for
Thank you. Thank you very
coming for today and delivering us a very great lecture. And sir, thank you so much for your thoughtful insight and scientific approach has provided meaningful guidance to students, researchers, and academicians and professionals. And we are truly thankful to you for sparing your valuable time and for your esteemed contribution to the success of today's session. Thank you so much, sir.
Thank you.
Thank you so much.
Thank you so much. Thank you, dear participants. Thank you very much.
Okay, so next for our today's session, we are privileged to have with us Dr. Ashok Kumar Sharma, who is a professor and head at GB Pant University of Agriculture and Technology, Pantnagar. And Dr. Ashok Sharma, sir, is a highly respected academician with extensive experience in teaching, research, and academic leadership. His significant contribution to agriculture education and research have played an important role in advancing scientific knowledge and capacity building. We are confident that his expert insight, rich academic experience, and practical perspectives will add great value to today's session and provide an enriching learning experience for all participants. We welcome you, sir, and you can take the platform. Sir, are you there? We are only seeing your screen right now.
yeah, no. Hello.
Yes, sir.
Uh, am I audible?
Yes, sir. Yes, sir. You are audible.
Uh, Hello. Me, Dr. A.K. Sharma. I am from GB Pant University, Pantnagar station at Dehradun. I am basically horticulturist and have been in the business for the last 25 years. And now, with the advent of technologies, I have been given a topic on the rooftop farming. I will be covering the topic within a stipulated period in 25 to 30 minutes, maybe 40 minutes. And again, I'm thankful to the chairman of this session as well as the Just Agriculture to share. They have given me the opportunity to share my experiences on rooftop farming, and I also welcome all the fellow students and scientists over there. And I will be giving a brief accounts about the rooftop farming that is going on there. Yeah, Praveen. Yeah, Praveen. Uh, Slide is not moving, please. I moved your slide. Yeah, okay. Hello. Yeah. Hello. Am I
Uh,
audible there? The
yes,
slide is
yes.
moving. Yeah.
Yes, sir. Yes, sir. You are
Yeah,
audible.
I'm just cutting. Yeah. Dr. A.K. Sharma, another for me that the rooftop gardening or the rooftop farming is there, then I will be giving a brief account why what is the need of this one in today's concern. We know that in the urbanization it is becoming very difficult in bigger cities that life, how to sustain the life over there. And we know that there is a lot of glut from the urban rural areas. They are moving to the cities, and cities are becoming bigger and bigger. And moreover, the climate, I will the microclimate of the cities is it's becoming very difficult to stay over there. And now the alternatively there is approach nowadays for each and everyone is that we can go for the roof gardening. Roof gardening is nothing but it is simple a technique wherein that in a periphery of your area, wherever you reside over there, the on your roof or your place, whatever available with you, that one has to use the space for your maximum use, maybe for the decorative purpose or maybe for the uh, the 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 growing of vegetables there. I will be covering this topic here for growing vegetables on a rooftop farming as well as the floriculture part over there. And this decorative benefit of is there, and roof plantation may provide even that the food and the temperature control, which is more important nowadays in bigger cities, and hydrological benefit is also there, and so that it also provides habitat for wildlife which we generally stay with our families over there, and it has a recreational opportunities there and bigger concern over. And now the roof garden nowadays in bigger cities there, if you move in outer side that here there's a photo this from by Hanover city that now they are placing in a bigger cities or they are maintaining the gardening in a bigger place and it become decorative, which gives an other so many benefits for one and all. And why we need the roof gardening? That is basically is we know that nowadays that our arable area is shrinking day by day. We are thinking for the area in a vertical air. The vertical farming is becoming nowadays more and more popular. And secondly, that the benefit of roof gardening is that we're reducing the urban heat island effect. That is more important nowadays. Bigger cities, I will say the cosmopolitan cities, they are becoming inhabitant just due to this one a problem because we have a lot of population there and temperature and anything so much carbon dioxide evolution, so many factors are there which are becoming serious over there. And nowadays, by growing these plants over there in our rooftop, that it also reduce in greenhouse gases, and it also provides some space for agriculture, and sometimes that it increase the beauty of the cities. That is more important nowadays. And nowadays, that is, we know that the monotony of our life, we need some place for the relaxation, for tiring over for day. The whole day we become busy, our stressful life. We need some relaxation and the tiring mind. Therefore, that is there that we need, especially that hobbyists or anyone who's reside in the cities. The only option is roof gardening or indoor gardening is there. That is the benefits of rooftop farming. And one data is there in agriculture area last 25 years that urbanization is increasing. And nowadays, even in some countries like Japan and sometimes in some Western countries, that they also give hill allowances those people who stay in the hilly areas. Reason being, cities are becoming bigger and bigger, and life is becoming very difficult over there. That is a policy issue for the one and all, that in a hilly areas, for example, in Uttarakhand also, so many people there, they are moving down to the even the national capital, even in Dehradun. That areas, that these cities are becoming very expanded over there. And this is just an idea that how much area we every year we are decreasing by this urbanization. And now the roof gardening, that it offers an opportunity for both type of plants, maybe the sun loving or shade loving plants. We can grow in agro sheds as well as in the available space over there. And the size of garden which we think it of there, it can be formal, informal type of garden we can maintain, wherein that we do not make any that formality over there, just like our Japanese garden are there. Japanese garden type of there, where is symmetry, contrast, and these are kept over there, especially in Google garden. But in formal garden, we do not keep such points over there. That is the place where we maintain the area as per our need and as per our requirement. That is basically a that for us, that provide a subsistence as well as the idea. Some glimpses that some in a smaller area, where in small farmers or the I will say that the city dwellers, they are using their space for so as to give the best place to live on the floor. They are just maintaining all type of these plants. This is the some example from our city here. And the glimpses that wherein some hobbyists, they are using the space, maximum space. They give a relaxation for them in the morning and the evening hours. Just glimpses over there. Now here basic question arises that now that if we use the space over our rooftop, there are two, three factors which are directly involved in our planning here. Can our this area will support the loading capacity of our roof? That is more important. Secondly, is the drainage part. And thirdly is the maintenance of the rooftop gardening. There are three main factors which also one must keep in mind before going for the this expansion of this. I will say the roof gardening. First is there the loading capacity. Invariably, we generally say that's one data is there. If our roof system is there, the extensive system, intensive system, rooftop containers, and hydroponic system, that they have given the one basic data is the weighing range is how much area, how much weight must be there so we can sustain over there. That is a rough idea. That 50 to for extensive system is that 50 to 200 kilogram per square meter area. Intensive system is 200 to 1000 is there. This is a basic idea that an architect and as well as the planner of the city, they give this type of data, that we have the soil, decking material, planter, these type of things that must be in our mind before starting our rooftop gardening, because these are some of the areas which needs immediate attention before starting this one. Secondly is drainage. This is very important. We know that we are going the farming over the area or the rooftop, and that area must be free and it must be clear in our mind that overall whatever the irrigation water that must be drained out, and the overflow scuppers that must be there. And on rooftop, even the faster flow of water, that how it is, how it will be managed over there, and where this water will be collected and where that can be utilized further or after clarification, or it may be in a drain. That the drainage part is second most important factor before going for the rooftop gardening. And thirdly is the climber and annual roof. These are some of the factors we generally include our rooftop gardening, and this is becoming an issue. And third is there, so as to maintenance of this rooftop gardening, the drainage and maintenance, repair, install, and rooftop gardening. These very important sections which we keep in our mind. And one thing is there, okay, that before designing the rooftop gardens in all sections, there's some area it needs to be clear for repair purpose, or sometimes some problem arises over there. It is not like that, okay, the whole of the area may be utilized for all this purpose by using the poly bags or maybe the container all over there. And third is very important there. Whenever we take the weight of each plant and the weight there, that the wet soil is taken. Sometimes we can make it okay. That is empty. I will say that the container is there. We generally keep record of all these things, and when we fill the compost and the soil mixture is there, we generally take the data over there before planting this crop. That one must be keep in mind the wetting soil data along with plant. That must be the weight. That must be taken into account. And fourth one is the choosing of plants. Which type of plants we generally use there. For rooftop, there's a unique and often we generally have there is a very extreme microclimate is there. In summers, sometimes there's very hot there. In the winter, the climate may be cooler one there. In order to maintain those plants, the choosing of those plants which withstand the it's a harsh climate over there. That the selection of plant must be there, and sun and wind is very important issue over there. That must be keep in mind. There's those plants which can withstand the direct sunlight, even the light intensity and wind direction and wind, even the wind flow. There are some of the factors which must be keep in our mind before choosing those plants. So there are so many plants over the annual, biennial, shrubs that is there. Third is that the soil. Before going for these plants, the soil depth is important factor. This must be grown on a root surface, and availability of water, how we can use this water in summer, especially in summer. The garden, the plant needs more water. That is in general, that before planning all these things, that must be in our mind. Other features before going for rooftop farming is the composting, and composting before composting we make sure that adequate drainage is there. That is that we generally. And the rooftop does not tolerant to compost material, and maintenance must be there, and sitting is important consideration before planning for the rooftop is there. And load bearing capacity of roof, that we already I've given the data that even our that the any planner who is planning for this one, that must be in our mind, so that our proper drainage is there and maintenance of these plants can be easily there. And the type of roof garden, we have three type of roof garden we generally plan it. That is basic of their shallow system is there, the ultra extensive, extensive, and intensive roof gardens are there. And wherein that is important there, that is they had given the data in pounds and feet, that is 4.8 to 6 pounds per square feet area is the weight over there that must be there on a per unit feet area. But in the growing media, that is the growing media is that 2 to 4 inches is there, growing systems. And medium type is their garden system, wherein the 50 pound per square feet area is the that must be the weight over there on a per unit basis. That we generally call, because that the soil depth is there, that the selection of soil depth depends upon the type of plants which we are going to grow over there. Fencing system is there, wherein the surfaces are very wide. We can use different type of media, and the weight basis that roof must be enough supportive that will withstand the weight of this one. Now, why we rooftop garden is there? It is helpful in urban heat island effect and reduce amount of greenhouse gases. It provides space for agriculture, reduce water storm, and reduce energy consumption, increase the beauty of city. That is there, and that is more important. The mood flickering by reducing stress and self gratification. That is the point. Now coming back to the science and technology that involved in roof gardening is that there are only three methods in general physics in high school. We generally read there: the conduction, convection, and radiations. then transfer heat by conduction, by growing plants on a big buildings, then by transfer there, we generally transfer heat into the plants into the building. But by using these plants, we can conduction method or through convection method and radiation, the heat which is directly heat up our buildings and other thing, the plant become a barrier as a buffer for to, to avoid them to lower down the temperature over there. And the urban heat island effect is the phenomenon and by which the ambient air temperature in cities is higher. In the we generally know that in cities the higher temperature is there and the surroundings urban and rural areas. And because that in material, generally the concrete and we know that so many material asphalt is there, we generally use there in a building construction that radiate more heat than the natural surfaces. And tall building is there which reflect, absorb light and block winds. And the waste heat is there by using this so much of air conditioners, industries and power. There's so much heat is involved there. In order to reduce the effect there by these plants, they use as a buffers, I will say, they affect weather and climate. That is the point there. And by using this one in a bigger cities, that materials that I've already discussed with you, that is tall buildings and waste materials there, because this type of the rooftop farming, they provide as alternative to common roof material, reducing temperature, they absorb carbon dioxide and photosynthesis, and these plants they create shade for the building. And materials is there, the reflector, insulator, and absorber is there. They are also part and parcel in construction of building. They generally are part wherein the heat part of, especially in bigger cities, increase by using this one rooftop farming. They help in by lowering down the temperature there, and the color, light, and heat parameters also there. All color absorb light, reflect only on the wavelength of the color. We generally that is their white reflects light wavelength of light. Black body radiation is there by using the black radiate material over there that has a more capacity to absorb the heat, and black surfaces generally are more hotter in color. These are some glimpses where in the bigger cities how we can use this one. How do plant reduce temperature? That again that it provides alternative common root materials, carbon dioxide, sunlight, and photosynthesis and shade light. And photosynthesis is very simple. That is, there's no need to explain over there. That invariably when the temperature high is there, the carbon dioxide absorbed by the plants. That's why the level is they're helpful in reducing the temperature there. Constructing a rooftop gardens, that we can go for this one. And construction of roof. The roof of garden is very, it must be very strong and waterproof. And even architect and civil engineers expert. That in general there, the 48, there's so many data sometimes there, but especially the engineers expert, there's the reference is there. I got the reference so many places there, but this data is there's 48 kilogram per square feet area is wherein it must be strong enough to provide strength in order to start the rooftop farming there by using this data. And after construction roof, it is better sweat polythene sheet. And I will give you the detail in a further slide that how this so many 4 to 5 layers are there essential in order to start the planting system. And before starting this one, that 800 days thickness of roof before making the lawn and flower bed and rock is there. And the plan of roof garden, it must be prepared before the construction time. That building must be lawn, rockery, ponds, and necessary brick, cemented edge, and protection from soil erosion and holding water. These some of the factors that must be keep in mind before starting that we will go in future, especially in bigger cities. This is the trend is becoming there that even the architect or the city developer nowadays considering these factors before giving permission for the construction. That is there in European counterpart in the bigger cities. In Chandigarh, even some Dehradun cities not proper there, but sometimes nowadays the new building they are giving such permission for them. At the city beautiful part, it must be there that there even the rooftop farming or the hydroponic system must be there in a city beautification. That is becoming a part. Some building they are using this one. Soil, the soil loam and fertile loam and clay that is invariably that we generally use for that is the basically the 1:1 ratio we generally use in most of the time. The annual perennial shrubs, climber and grass crops, whichever we think that fits in our system, which we invariably we like, we want to include our garden there. The layout is size and shape of the lawn, rockeries, water pools, shrubs that must be there, manures and fertilizers by using this fertilizers in 1550. That's now available nowadays. The regular practice, and these are some of the points must be in mind before maintaining our garden, rooftop farming there, or the garden there. And that's important part is the lawn making. That is a very stressful work in order to maintain the lawn, with constructing a lawn and maintaining the lawn. So very important there. It takes a lot of care for maintaining the lawn. And some of the point is there. Even we are going for the Josia grass there, or maybe the other grasses, in order to make is a big, thick blanket over there. And the maintenance of especially all this, maybe it requires a lot of attention. The construction of rockery and water pool and pathway. There are some of the elements. Nowadays, in extensive roof garden, these are becoming important part. They are the rockery, water pool, and water wheel. Just with we know that our society, there's this in a bigger cities and a bigger building, these are becoming part. And so far as the horticulture crops in the roof gardening, anthurium, orchids, and they are the some of the plants. They are shade loving basically. Anthurium, orchids, and house plants are so many. They require 70-80% of shade. And some orchid is there that needs less shade purpose. They can withstand the direct sunlight. And black cemented gerbera, standard chrysanthemum, carnation, and they can be they can sometime they can be they require even the shade for their proper growth and development. Even the 200 micron sheet is enough for them to sustain over there. And suitable housing plant, bonsai, these are some of the plants nowadays being utilized and being used in a house garden, in a rooftop farming extensively. We philodendron is but bigger plants with a perennial in nature. And thurium is there, the northeast part is there, not in the plain area here. Alopecia aloe is there, that is there. Syngonium is that can be used anywhere. The postern form that is in a bit cooler climate. Next comes the bonsai culture. Even in our cities, that some farmers nowadays they are making the bonsai culture as a tradition, and nowadays in a usual festival, this bonsai is being sold. In Dehradun even. Now, the suitable sun-loving plants. There are rose, chrysanthemum, derba, and among the shrubs is there. So many shrubs is there. And the hydrangea, ixora, zendra, fortunilla, japonica, and the climbers, bougainvillea, the clerodendron, and Campsis grandiflora. These are the plants. They are sun-loving plants. They can be used in our, especially in a rooftop farming. Extensively being they are used. And arrangement of flower in the rooftop. Sometimes when there is plants which require less water, they are cacti and succulent. They are being used nowadays in a bigger way. And arrangement of rooftop farming. They are some of the plants, how they will manage in our little space where we have less space for them. There's a year-round production of roof gardens, January, February, March. I can read the annual shrubs and pot plants. Then that power the chrysanthemum, Gerba gladulus that will in February months. There's so many there, even marigold, pansy, that annual, and as well as the perennial plants. They are when we have some Rabi season or Kharif season or summer plant, say annuals, they are grown in different parts. As per our choice, we can use in our planting system. There's a year-round production we can use when they are planting time and then say harvesting time. Not harvesting, I will say that when it is the cut flower will be used or the loose flower will be used there. Arrangement of flower and hanging basket. That's important nowadays. Is used nowadays. It has a lesser space to occupy, but it gives aesthetic look for our surroundings. Nowadays, this hanging basket are being extensively used in the city, even in the local level, even the small households, they are using this hanging basket for the bigger. Even the terrace gardening, the bigger way we have local stone, bricks, concrete, wood, gravel, mosaic they are using, and the outdoor living rooms for relaxing area. Those are the bigger building, bigger houses. Those people are maintaining there. These are the they are using local material even, and these are some of the terrace gardening and the relaxation. And this top gardening is used for creative relaxation of rooftop. The flowering is there, flower arrangements. Flower for two prof. I'm just giving some details and 2D image there. This is glads, and then this is chrysanthemums, and these type of plants are hollyhocks, even the chilies. They are being used on rooftop farmings. Flowering on rooftop is there. You can use these places for your, and these are rare collection of is the football lily and about the poinsettias. A rare collection of rooftop that is maintained, and the flowering rooftops that can be used with the carnations, dahlias, even gerberas, materials can create rooftop gardening. That is the that I'm just talking about how the tech is made there. Typical material for rooftop gardening includes plants, growing materials, growing medium, decking or material, and sitting. There are the six layers we generally use there. Their thickness is depend upon which system is you are using there, the extensive or intensive system, and the plant type which you will be using in future. Maybe whenever using perennial plants, its thickness will be more invariable. Height and weight calculation is the extensive root system is there. There is a definite method wherein the height and weight calculation table extensive root system. This table is given. And the deep intensive system, that is the data is, I will not give in detail. That is the weight basis per feet basis or per square meter basis. The data is there nowadays. We have 50 kilogram per square meter basis is the standard method wherein we use the and constraints of the garden, the conditioning of the roof, that is there, the structural capacity of roof. We have basic problem with the roof garden, excess of roof, cost, irrigation and drainage. These are some of the factors which directly or indirectly influence the this rooftop gardening that must be keep in mind. And these are the factors before we know that these will be the limitation in future for rooftop farming. And second part comes the rooftop vegetables gardening. That is, and rooftop that is sometimes it also gives us value, aesthetic value as well as some it gives the demand of vegetables on a daily basis also on a rooftop farming. The more demand of vegetables is increasing population, and we know that 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 is this type of plants if you grow in a local surroundings they can grow that can meet out our some basic the food requirement also. We can grow there cucumber, potatoes, even the pole beans and tomatoes can be grown on a rooftop. And before going for vegetable roof gardening, there are some steps there. The preparation, design, making, and maintenance. There are four steps. Preparation is survey, measuring availability of space. Designing is there. The way we want to produce the vegetable on our uh, top roof, and making structure and maintenance. There are 4 points there before going for the vegetable gardening. And these are some of the steps wherein we can go for nursery raising. How these will be hardened and they will put in a space where is the finally it will be transplanted. Some of the steps in vegetable. And the constructing rooftop gardening, we have suitability, assessment of roof, moisture blanket after pouring levels, even the grading system, deciding irrigation system, choosing soil criteria, suitable plants. That is there. And there are two types of extensive intensive system there, wherein the 6 point is there, the growing method, depth is there, accessibility, fully saturated, weight, how much is there, planting density, cost, and maintenance. On that basis, these two types of system for making the roof garden, they varies. And for a model, if we have the area of 7 by 7 meters, we have a planning that we can make the row wise, width wise, how much area will be utilized, and in a year, the different type of vegetables we can grow. Season wise is there. And this is the one data over there in an area of 230 square feet. That will meet out the requirement of 30 to 35% of the family of farmer. And that is data is given that 61.7 kilogram of vegetables produced in a smaller area, wherein the amaranthus, eggplant, carrot, coriander, methi, and the chilies, they will be grown in a containers. It will gives it will meet out the requirement, daily meet out of dietary requirement of vegetables in our food. And different type of microgreens nowadays. I'm just touching this factor, the main basils, parsley, thyme, cilantro, and chives. These are some of the easily grow in mason jars that can be grown that will meet out our requirement of micro. There are so many families there. There's a Brassicaceae, Astraceae, Amaranthus family members that can be used in a microgreens. And these microgreens are basically they are fast food ready in a few days as more nutrition qualities, and they are digestible form that can be grown home by anyone. And there are so many alfalfa, almonds, barley, broccoli, buckwheat, and chickpea. There are so many there. Soaking time and sprout down, how will that be easily available for the food purpose. And the another one system is there in a very small space in area in a higher, in a bigger cities, wherein space is the basic limitations, wherein in a bigger cities nowadays, the Dutch bucket system is very useful. Where small hydroponics, closed hydroponic system is used in a very small space, wherein the demand, especially of tomato and daily need can be met. That's a Dutch bucket system, it's small system. So many people nowadays they are using this bucket system in our local system. And now that is very costly one, but the simplest one is that the growing ginger in mini bags on the rooftops. Very simplest and simple, wherein the expensive will be less. Nowadays, the grow bags is there, they are being used, and there are some I will say buckets there where we can go for growing this one zucchini that is grown there. That will meet out the requirement of daily food requirement, and especially any I will say the wastage, the tire, anything that can be filled and that can be used for. There's one idea that on our rooftop we can go for using the waste material and grow useful vegetables that can be used in our daily food. This is the is some view of top roof farming wherein this type of crop are gone. The one glances some, and this is a glance too, and a few plants which can be grown ornamental as well as some other plants. And then there are some glimpses, some ideas that by showing this some work of others, we can get motivated. We can go for in a smaller space. We can utilize maximum for our aesthetic gratification as well as to meet out the daily dietary requirements. So some glimpses. And a smaller area even, just like that, have a choice that especially the eggplant, white eggplant can be grown, and especially here that small space, the asparagus spears can be grown. Sometimes they're useful in nutriting. And lastly, conclusion that we know that in our uncertain future, climatic change, and day by day, this increasing population is increasing, and shrinking of agricultural land. We know that this rooftop farming is one idea where the sustainable and even the scalable approach to improve the food security. We know that area is shrinking day by day, and due to urbanization, and now the basically even the most of the in Indian condition, most marginal farmers are there. Their land holding is very less. By using this technique, by using a small space for our food security, and focus on food production, hence well suited enhancing food security in cities and reduce the impact of long transportation of vegetables. That is there. And the population increasing by pace by 2020 will become fast populated country in the world. Hence, there will be a need for the innovative strategies to increase the population of grains and vegetables. And the urban rooftop is new efficiently used for cultivating vegetables several tons of production put into the rooftop gardening. And this is in a nutshell the conclusion that where we can sustain. It will give the aesthetic satisfaction, I will say, the aesthetic values to the dwellers of the cities, and by reducing the urban heat effects as well as it provide food security for millions and millions of the city dwellers. And nutshell. And thank you very much. I'm thankful. I'm very much thankful to virtual agriculture and the participants who have been here, and they have given the opportunity to express a few points, or rather a very small topic, to share with you some of the slides and experiences. Thank you very much. Thank you.
Thank you very much, sir, for this great topic. As I want to say to the participants that if anyone have any questions, then please drop in the chat box. Sir, till then, I have a question that what are
Please.
the like major technical structure and economic challenges in adopting rooftop farming in urban areas? And how can they be effectively addressed for large scale implementations?
Ma'am, now we know that nowadays the population is increasing day by day, and that's, I have in my discussion, I have even explained it that now that urbanization is becoming a serious issue now, and in order to supply the regular food as well as to provide the aesthetic sense, I will say for the relaxation purpose, this especially the rooftop farming is very important for one and all. And nowadays, the government of India also make a policy over there that nutri gardens, that is a part of the top gardening, that become a important part. Even the Indian government, the central government has given that 5 ministries, even our the NRRM, even the HRD ministry, even the rural development, they have all that come to the conclusion that our dietary diversity, especially malnutrition and undernutrition, especially these two issues are becoming very serious nowadays. In order to mitigate the problem, and the only one solution for all this purpose for small and marginal farmer is going for the nutri gardens or the rooftop farming. We know that 70 to 80% population nowadays, they have a acreage is less than 1 hectare area there, or the most of the people now becoming landless. For them, in order to sustain themselves, this is the only option with them. Then a limited space, they can go for growing of vegetables and the floriculture plants. This gives them aesthetic sense.
Thank you so much, sir. And sir, there is also one more question from VK this side at how is heat is land problem addressed by rooftop gardening?
We know that, ma'am. See, whenever we are going for the rooftop farming, growing plants on the top surface or by hydroponically, we are covering the buildings or the walls with the ornamental plants. These plants become buffers. Even the light, even the heat effects, especially by conduction or radiations, their effect will be minimal there. That's why it become a buffer for them, and that's why the heat that will be increased by in the cities. That will be reduced by using these plants as a blanket over there. Or secondly, by absorbing the even the when we go for growing of plants, they will absorb the additional carbon dioxide which is being released by the hydrocarbons and anything over there, the greenhouse gases that will be absorbed by these plants. If we have a more of plants there in the surroundings, naturally the cooling effect will be there.
Okay, sir. And sir, there is one more question from Dr. Joya Rani, ma'am, that sir, what is the feasibility of fruit crop gardening in rooftop farming system?
There are so many plants that can be grown there. We know that there are two types of plants there. One is a seedling plant, other is a grafted plant. Grafted plant invariably have a root system is very shallow. For them, nowadays we can go for even mangoes and even the citrus that can be grown in a rooftop farming. That is quite possible. So many people are doing here. Even the perennial plants, even the papaya, as well as even the mangoes, some varieties, the Ambika variety, that's now being grown in a rooftop farming. Even mango that can be grown there. Citrus are so many. All the citrus, mostly I will say, even the this is the just chote wala nimbu or enchifolia is there, or the all type of citrus that can be grown in a even a containers. We have nowadays we have so many containers of different size. Even the grow out bags we can grow for this one on a rooftop.
Okay, sir. And dear participants, there is already written in the PPT, as you can say, see the mobile number and the mail ID. So if anyone will have any further questions, so they can directly contact sir or can send the query on the mail as well. Uh, right, sir?
Yeah, sure, no problem. My mobile number is 24/7 that is open. That can be talked, and my mail, even the email is there. If any queries, they are most welcome. I'm so thankful to you all. Thank you, ma'am. Thank you, Just Agriculture. They have given the opportunity to
Yes.
explain views. So nice of
Sir,
you. Thank you very much.
thank you so much, sir. So there is one more question from
Please.
yeah. What is the planning of manuring and economic balance for meeting requirements of market? And what is the plant growing planning? How to face the domestic and international market with the competitive edge?
See, though, ma'am, this is I will say this sustainable models. Rooftop farming is basically a sustainable model in order to meet the domestic demands. Our small, you know that area is very less. Whatever we are producing, that is for a family purpose.
Mhm.
We cannot think of the profit maximization or selling what we produce over there. The quality wise, nutritively, we are producing excellent material. We know that how we are growing this one. And the material, or rather, I will say that the growing media which we are using over there, that we know that which type of manures and any fertilizer. Even the sometime in our, especially in the rooftop farming, we are discouraged. We generally discourage for the even chemical fertilizers. We will be using mostly organic fertilizers, organic manures. Maybe it may be of a warming compost, maybe even the composting material that are extensively being used nowadays, especially on rooftop farming or in a kitchen garden purpose. Even the nutri gardens, even.
Okay, sir. And sir, I guess that's all with the queries. And we really thank you so much, sir, for delivering such an insightful and informative lecture. And your inputs and rich academic experience and practical perspectives on the topic on rooftop farming has greatly enriched our today's session. And your valuable deliberation highlighted the significance of rooftop farming in promotion urban agriculture, sustainability, and efficient resource utilization. Your lecture has provided meaningful insights and inspired to our students, researchers, academicians, and professionals. And so we are truly thankful to you for sharing your valuable time and sharing your expertise with us on this esteemed platform. Thank you so much, sir, for joining us today.
Thank you, ma'am. Thank you very much. Thank you all, audience. Thank you very much.
Thank you so much, sir. With this, the next we had Dr. Dayaram sir, who is a project director and Advanced Center of Mushroom Research, PUSA. But he was about to join us today on this platform, but due to some emergency, he was not able to join us today. But he will surely join us in upcoming days. So, participants, please do be connected. And with this, we come to the conclusion of day 7 of the 21 Days International Winter School Training Program. And we sincerely thank each one of you for your active participation and the thoughtful interactions and enthusiastic presence throughout today's session. And your energy, your curiosity, and eagerness to learn have truly enriched today's program. and making the session not only engaging but also highly impactful. Each question, discussion, and shared perspective has added tremendous value, fostering a vibrant learning environment. And we extend our heartfelt gratitude to our esteemed speakers and for sharing their valuable knowledge, experiences, and insights, and to all participants for contributing so meaningful to the success of yet another productive and enlightening day. So, as we move forward, let us continue with the same spirit and same energy and positivity and dedication to the next day. And may the knowledge gained and connections made today inspire innovative thinking and collaboration active in your represent fields. And thank you so much, everyone, once again for being such a wonderful, engaged, and inspiring audience. And have a pleasant evening and stay motivated. And see you all soon. Till then, have a good evening ahead.
Namaskar.